Alright, so let's talk about arc length as well as the formulas for it. So over here, what is arc length? So arc length is actually uh, a portion of your circumference. So let me just draw a circle to illustrate. Right? Let's say you have a circle. We know what the circumference is, right? The circumference is actually this the outline, the exterior of your circle, and very um, commonly, right, whenever we are asked to find the circumference, we use the formula of 2 pi r or your pi d, where d here represents the diameter, so diameter is 2 radius, so hence you have these two variations of the formula to find the um, circumference, right? To find the circumference of a circle. So now, if arc length is a portion of the circumference of a circle, how do we visualize it, right? So imagine I'm doing a cut, right? Uh, and this is like the center of the circle, right? So I'm doing a cut, and you will notice this is like a pizza slice, right? A slice of a pizza. So let's say, um, now I have this slice of the pizza. Arc length here is actually representing this exterior bit of the pizza slice, right? Which in maybe more layman terms, it could be um, the crust of your pizza. You can imagine it as that's the crust of your pizza, right? So how do we find this, right? How do we find the arc length? So if let's say I give you another pizza slice, right? Let's say I have a huge pizza slice, which is like the half of a pizza, right? If I have half of a pizza and I want to find the same length thing, right? The same crust of the pizza, what you would do is that you will tell me that that's just half the circumference, right? I'll just take maybe 2 times pi times r, and then I'll times half, right? So probably in lower sec or in primary school, right, you will have already did that if they want you to find the circumference of a semicircle, right? Which is in this case what we are doing, right? So arc length of a semicircle is like the circumference of a semicircle. So with that, I want to show you how to calculate this arc length using a very similar formula, but instead of putting half, because we will be putting a fraction based on the degree. Okay, so um, for uh, for a semicircle, right, the angle here is going to be 180 degrees, right? So if that's the case, instead of putting 1 out of 2, so half, I'll put 180 degrees over 360 degree. Now, putting this 180 degree over 360 degree, you will very quickly notice is the same as putting half, right? Because 360 degree divided by 180 is actually 2, so you get a half. So essentially, we are doing the same thing. The only difference to this formula is that instead of knowing that, okay, this is a semicircle, so if I want to find the arc length, it's half of the whole circumference. I will use the angle that I know is occupied by a semicircle. So the angle here that is occupied by the semicircle is actually 180 degrees. So I'll put 180 over the 360. Now, so with that, right, I can actually use this idea to find the arc length of any pizza slice, right? I can find it for this slice as well, right? All I need to do is that I need to know this angle here, right? So just like the semicircle, right? If I know the semicircle is 180 degrees, I can use it over here to find the arc length, the portion of the circumference. Now, if I know that this angle is, let's say, 60, right? 60 degree. What I can do is I can put 60 over here and I would be able, and using this formula, I would be able to find the arc length of this pizza slice, right? Arc length of this sector. All right. So in case you're wondering what do I mean by this sector, right? So you can visualize pizza slices as sector, right? So this let's use a different color. This blue one that we've already cut out, this is your minor sector because it's actually the smaller piece of the pizza, right? And then I can have the red one, the remaining one will be the red one, and the red one is actually going to be my major sector. So later on, I'll be introducing you to this concept of segment, but over here, sector first. Sector, the way to visualize it is, it's like a pizza slice, right? Or the way you will cut a cake, right? This is a slice of a cake. Now, so with this, actually, we have the formula for finding arc length for degree. And why I'm leaving this space here is to show you if you don't want to use 2 pi r, right? 2 times pi times r. You can also use pi times the diameter, right? Times 60 degree over 360 to find the arc length of this pizza slice. All right, so that is how you use, how you find arc length um, when you have the angle in degrees. All right, so now let me go through how you find the arc length if you have the angle in radian instead. So let's say now this is no longer 60 degree, right? This is angle given in radian. So if it's given in radian, say 1.2 radian, all right? So 1.2 radian, how do we find the arc length? So it's a very similar flow to this because the concept is still the same. This arc length is still a portion of the pizza crust, right? A portion of this. Uh, so if it's still a portion of the circumference, still the pizza crust, right? The formula will still be the same. So it's essentially going to be, I'm just going to duplicate this to show you that it's exactly the same, right? And now what will happen is that I'm just going to change the angle. Why? Because the angle now is no longer in degree, it is in radian. So I'll put 1.2 radian here, and I will put over 2 pi. Why? Because the whole circle is for uh, the angle of the whole circle in radian is actually 2 pi, right? Just like here, why I put 360 is because the angle for the whole circle in degree is 360 degree. All right, so switching it accordingly, this is the formula for finding arc length when your angle is in degree. I mean your angle is in radian. All right, and I can have the pi d one as well. So pi times diameter times, same thing, 1.2 over 2 pi. And what you will notice is that this 1.2, 2 pi, this 60 over 360, these are fractions that will tell you how much is the proportion of the whole circle. How much portion of the whole circle are you trying to find the arc length of? All right. So previously, if it's a semicircle, we'll put half here. So now, if it's 60 degrees, we'll have to find the portion and then put it at 60 over 360 and multiply by the same formula. And if it's in radian, we are doing the same thing. So 1.2 over 2 pi will give you the portion of the circumference multiplied by the same formula. All right. So with this, you will be able to calculate the arc length of uh, any portions, right? As long as they give you, or as long as you have the angle, regardless whether it's in degree or if it's in radian. Okay, so over here, for the formula for radian, quite commonly, students will ask me, okay, this looks a little different from what my maybe teacher taught in school, right? So my teacher taught me this other formula called R theta. Okay, so if you find this familiar looking or you have been taught this R theta formula, let me explain and show you where this R theta came from. All right, so this R theta formula is actually the same as what I've taught you over here. Oh, all right. How is it the same, right? It doesn't look the same. So imagine or assume that my angle is not 1.2, right? I don't know the angle, so that's why I'm gonna use theta over 2 pi, right? Instead of 1.2. I'm still gonna use the same formula, the same 2 pi r, because based on what I'm saying, that's the same formula that will give you your r theta. So let me show you how they are the same. So if, okay, allow me to zoom in a little more on this. So if you were to simplify this equation, you will realize that 2 times pi times r, these are all not fractions, right? So your theta over 2 pi here, these are actually fractions. So what I can do is, if it's not a fraction, I can put it as over 1 first, over 1 over 1, right? So 2 is 2 whole, right? So 2 whole can be 2 over 1. And then what you will realize is that your equation will very quickly change to 2 is to what? 2 over 1 times pi over 1 times r over 1 times theta over 2 pi. And you probably will know or realize that fractions, whatever that is on top and whatever that is below, I can cancel away. And then you will get r theta that is left on top, right? If this method is a bit uncomfortable for you, we can still go ahead and combine all the fraction first, right? So fraction times fraction is actually going to be your top times your top, or your numerator times your numerator, or your denominator multiplied by denominator. So you're gonna get 2 pi over 1, right? And then multiply by your r over 1. So that is 2 pi r over 1. Then after that, you still have this theta over 2 pi. So same thing, fraction times fraction, top times top, bottom times bottom. You will get 2 pi r theta over 2 pi. Since on top there's 2 pi, below there's 2 pi, you can cancel out the 2 pi. R theta is what you're left with. So what I've shown you here is that the formula that I just mentioned is the same as the r theta. All right. So another question that I may get at this stage is, so if these two formulas are the same, then why don't I just learn the r theta, right? It's so much like shorter. I don't have to write so many things, right? I don't have to write this whole thing. Oops. Okay. Let me jump back to this. I don't have to write this whole thing, right? Now, the reason for not using r theta or not memorizing that the formula for arc length is just r theta is because your r theta can only work if your theta, okay, let me just note it here, if your theta is in radian. So that means your r theta can only be used in this branch, in this section, where you are using the formula to find the arc length when your angle is in radian. If your angle is in degree, you will not be able to use your r theta. So because of that, this may cause some problems for students who just memorize arc length is r theta and they use it regardless of whether your angle is in degree or your angle is in radian. Because just now, the proof that I show you works for the formula for radian, but it doesn't work for the degree one. So since it doesn't work for the degree one, it cannot be used for the degree one. So instead of memorizing r theta, what I usually teach my student is use your formula for circumference. And go and see what's the portion of the circumference based on your angle that you're trying to find the arc length of, right? Just put the angle over the whole thing, your 360-degree. Just put your angle in radian over your whole 2 pi, and you'll be able to calculate your arc length, because arc length is nothing but a portion of the circumference. All right, so hopefully this is clear, and this explains why we are not going to be using the r theta, but I still want to show you, because in case it comes out as a proof question, right? Proof that this arc length is actually this formula, then you know how, right? The proof is actually this, from this formula. Okay, so if you're good with this, let's move on to the example below. Try it first, and we'll go through in the next video.